Okay, so moving on from the elimination method, we're going to solve simultaneous equations, this time using the substitution method. Okay? So I want you to write the definition. You've got a space here for what you think solving means and what you think to substitute means. Okay? Pause the video, write the definitions, and then I'll tell you what they are. So, solving. It just means to find the value of either x or y in this case. To substitute will mean to replace, or replacing one thing with another. In this case, we're going to be replacing one expression with another expression. Okay? We'll start straight away with an example. Y equals 2x minus 3 and y equals 5x plus 6. So these are in a slightly different form to the previous one. They're still equations, they're still linear, they don't have any powers. So what we can do, we can say, well, we've got y is equal to 5x plus 6, but y is also equal to 2x minus 3. So we can replace y in equation 2 by 2x minus 3. So we can say that 2x minus 3 is then equal to 5x plus 6. Check that you're happy with that statement. All I've said is that, well, y is 2x minus 3 and y is also 5x plus 6. So I can replace the y I've circled by 2x minus 3. Now pause the video and just solve this. So, taking away 6 from both sides, you get 2x minus 9 is 5x. Taking away 2x from both sides, you get minus 9 is 3x. And then dividing both sides by 3, you end up with x is equal to minus 3. Now we have to find the values of both x and y, so I sub x equals minus 3 into equation 1. Okay, so equation 1 was y is 2x minus 3. So this is 2 times minus 3 minus 3. 2 times minus 3 is minus 6. Minus 3 is minus 9. So y is minus 9. You could check this if you weren't sure. Or you're in an exam situation, want to make sure you've got it right. Right, we're going to look at another example now, slightly more difficult, and there's lots of ways you could do it. Okay, so 2x plus 2y equals 20, and 3y is equal to minus 5. Label them equation 1 and 2. Okay, so this is slightly more difficult. It's not as easy as the one on the left-hand side there, because in that one you just had y was equal to stuff and you could substitute very easily. In this one we don't have the same situation. I mean, we could take equation 2 and we could divide both sides by 3 and give us y is equal to a third x minus 5/3, but that's quite difficult. But what we do have is we have that lone x in equation 2, so we could rearrange equation 2 to make x the subject. It's all about finding these little shortcuts. So, rearranging, we could add 5 to both sides, giving us 3y plus 5 is equal to x. Okay, so I've got that x in equation 1, and I've got an x here. X is 3y plus 5. So I can replace it, I can substitute 3y plus 5 into equation 1. Okay, so doing that, I get 2 brackets 3y plus 5, plus 2y equals 20. Okay, apologies, I realised the question up here was in fact a minus sign. That should be correct on your sheet. So this is 2 brackets 3y plus 5 minus 2y is equal to 20. Expanding the brackets, 6y plus 10 minus 2y equals 20. Collecting like terms gives 4y plus 10 is equal to 20. Subtracting 10 from both sides, 4y equals 10, and finally y is equal to 2.5. Okay, now we've found y, we can find x by substituting y equals 2.5 into, say, equation 3 in this case. So 3y plus 5 equals x. Y is 2.5 though, so 3 times 2.5 plus 5 equals x. So 7.5 plus 5 equals x, which means that x is equal to 12.5. Now you could check this by substituting x and y into equation 2, and make sure that everything made sense. Okay. Next time we'll be looking at solving non-linear simultaneous equations, which will rely on this substitution method, so you must practice this